UGC NET Electronic Science February 2023 Question Paper Solutions Part 3 from question number 51 to question number 75. Question number 51. In case reverse bias photodiode is kept in dark condition, which of the following through the device corresponds to? Correct answer is value of reverse saturation current. In a reverse bias photodiode, when kept in a dark condition, the current flow is only due to thermally generated carriers, and the current is called dark current or reverse saturation current of the diode. Even in complete darkness, reverse bias photodiode conducts a small reverse saturation dark current due to thermal effects. Correct answer is option 2. The value of reverse saturation current in reverse bias photodiode when kept in a dark condition. Next question. The diode used in figure below has a threshold voltage of 0.5 volts and a forward resistance of 4 ohms. Calculate the current flow ID through and the voltage drop VD across the diode. Given in the circuit diagram, the diode D has junction potential of 0.5 ohms and forward resistance of 4 ohms. Replace the diode with internal circuitry. So this diode is replaced with the internal circuitry, 4 ohm internal resistance and 0.5 volts junction voltage. Given forward resistance of the diode is 4 ohms. Now apply KVL in the loop. Apply KVL in this loop for finding the drain current ID. So drain current ID is 5 volts on minus 0.5 volts divided by total resistance 4 plus 1000 ohms. That is 4.5 volts divided by 1004 ohms. So we will get the drain current ID as 4.48 milliamperes. Now VD is equal to 4ID plus 0.5 volts. So voltage drop across this diode. The current flowing through the diode is 4.48. VD is equal to 4ID plus 0.5 ohms. Now substitute this ID in this equation. On solving, we will have the diode voltage across the diode VD is 0.518 and current through the diode is 4.48 milliamperes. Correct answer is option 3. Next question. Question number 53. What current should flow through D2 diode? Consider the values given in the circuit below. And this is the circuit given. In this circuit, we need to calculate the ID2. Let us assume this point has node A and this is loop L1 and loop L2. First write KCL at node A, that is incoming current I2 is equal to ID2 outgoing current and I1. I2 is equal to sum of incoming currents is equal to sum of outgoing currents. So incoming current is I2, outgoing current is I1 and ID2. Apply KVL in loop 1. So that is 0.7 volts plus 0.7 volts plus 5.6 kilo ohms into current flowing through this 5.6 kilo ohm is I2 current is equal to 20 volts, which is a source voltage. Now on solving, the current IT is equal to 20 minus 1.4 volt divided by 5.6 kilo. Current I2 on calculation we will get 3.321 milliampere. Similarly, apply KVL in loop 2, that is 3.3 into I1 is equal to this voltage drop. This voltage drop is 0.7 volts. Voltage drop across diode D2 is 0.7 volts. From this current I1 is 0.2121 milliamperes. Now substitute this I2 current I1 in this expression. So we will get IT is equal to ID2 plus I1. So from this, I2 is 3.321, I1 is 0.2121. So from this, current ID2 is 3.11 milliamperes approximately. So correct answer is option 3. Question number 54. The ratio of peak to peak ripple voltage to peak ripple output voltage is known as ripple rejection ratio. Correct answer option 4. Ripple rejection ratio is input ripple voltage to output ripple voltage. Ripple rejection ratio or power supply rejection ratio or supply voltage rejection ratio is precisely the measure of how well a circuit reduces input power supply ripple at its output and is expressed as the ratio of input ripple voltage to output ripple voltage. In terms of dB, it is 20 log 10 input ripple voltage to output ripple voltage. Question number 55. The approximate oxide capacitance CGD for saturation operating mode of MOS transistor is. So correct answer is option 3. For a MOS transistor operating in saturation region, the channel is pinched off near the drain, but the gate is still capacitively coupled to the depletion region at the end. So effective drain gate capacitance CGD is COX into W into LD, where COX is oxide capacitance per unit area, W is channel width, LD is length of depletion region near drain. And this option 4 represents total gate capacitance. Question number 56. In NMOS transistor, if N plus region is diffused in P type substrate, the type of PN junction generated towards channel and drain is. It is N plus P type PN junction is generated towards channel and drain. In NMOS transistor, when N plus region, source or drain, is diffused into a P-type substrate, the PN junction is formed between N plus heavily doped N-type source or drain and P lightly doped P-type substrate or channel region. N plus P junction is formed. Question number 57. For N-channel MOS transistor with mu N 600 centimeter square per volt second, COX oxide capacitance 7 into 10 power 8 10 power minus 8 farad per meter centimeter square, width 40 micrometer, length 4 micrometer, and VTO threshold voltage 1 volt. The value of K parameter is. So in N channel mass transistor, given electron mobility 600 centimeter square per volt second, oxide capacitance 7 into 10 power minus 8 farad per centimeter square, width 40 micrometer, length 4 micrometer, threshold voltage 1 volt. So from this K parameter is mu n COX W by L. So mu n value is 600 centimeter square per volt second and COX is 7 into 10 power minus 8, W by L is 40 micro by 4 micro. So on solving, we will get K parameter value as 42 into 10 power minus 5 ampere per volt square. Correct answer option 2. Question number 58. Consider a resistive load inverter with VDD 5 volts, K dash 20 microampere per volt square, VTO 0.7 volts, RL 500 kilo ohms, W by L ratio 3. The value of critical voltage VOH. For a resistive load NMOS inverter, VOH is the output high voltage, the output voltage when input is low, since it is an inverter. So output voltage is high. So output is high means input should be low. If Vn is equal to, if input is 0, nmass is off, nmass is off, then drain current is 0. That is no current flows through the load resistor. So no current is flowing means no voltage drop. So that means no voltage drop in within the inverter. That is output voltage is equal to supply voltage, which is 5 volts. Correct answer option 4. If input is 0 and mass is off, drain current is 0, the current flowing through the circuit is 0, no current is flowing, no voltage drop. No voltage drop means output voltage same as input voltage. Question number 59. For series RLC circuit given in below figure, choose the correct answer based on Kirchhoff voltage law from following. So given series RLC circuit and the current flowing through series RLC circuit is I of t, resistance R, inductance L, capacitance C, and voltage source V of t. So from this KVL is supply voltage V of t is equal to voltage drop across all the components in the circuit. That is voltage drop across resistor VR of t, voltage drop across inductor VL of t, and voltage drop across capacitor VC of t. So from this V of t is equal to voltage drop across resistor is V is equal to IR, R into I of t. Voltage drop across inductor is L di by dt. Voltage drop across capacitor is 1 by C integral I dt. So from this correct answer is Ri L di by dt plus 1 by C integral I dt is equal to supply voltage V of t. Correct answer is option 2. Question number 60. The unit parabolic function is represented by its Laplace transform as unit parabolic function p of t is equal to 1 by 2 t square into u of t. That is t square by 2 into u of t is a parabolic function, unit parabolic function. So for this Laplace transform is p of s. Laplace transform is p of s is equal to Laplace transform of p of t. That is Laplace transform of t square by 2 into u of t. So we know that Laplace transform of t power n is equal to n factorial by s power n plus 1. So here n value is 2, 2 factorial by 2 plus 1, that is 1 by s cube. So 2 to get cancelled, we will get 1 by s cube. Similarly, for a step function, Laplace transform is a by s. For ramp function, Laplace transform is a by s square. For parabolic function, a t square by 2, and its corresponding Laplace transform is a by s cube. If it is unit means then a value will become 1. Question number 61. Two-port network is given in figure above. Select equations for transmission parameters from the given below equations. So for a two-port network with port 1 as input port and port 2 as output port, V1 and I1 are input port voltage and current, V2 and I2 are output port voltage and current respectively. The transmission parameters are V1 is equal to AB2 minus BI2, I1 is equal to CB2 minus DI2. These are the expressions for transmission parameters of a two-port network. Correct answer is option 3. Let us see other parameters, expressions for other parameters. Z parameters, for Z parameters, V1 is equal to Z11 I1 plus Z12 I2, V2 is equal to Z21 I1 plus Z22 I2. For Y parameters, I1 is equal to Y11 V1 plus Y12 V2. I2 is Y21 V1 plus Y22 V2. Transmission parameters are ABCD parameters. V1 is equal to AV2 minus BI2. I1 is equal to CV2 minus DI2. Z parameters are inverse hybrid parameters. I1 is Z11 V1, G12 I2. V2 is equal to G21 V1 plus G22 I2. These are the all parameters of a two-port network. So here correct answer is option 3. Question number 62. For a Fourier series of waveform shown in figure below, select the correct expression for f of t. So this is the waveform given. For this periodic waveform, we need to calculate the Fourier series. Given waveform, for given waveform, for time period 0 to t by 2, its amplitude is a. From t by 2 to t time duration, its amplitude is 0. And this is a periodic waveform which replicates for each and every time period. So from this expression for to obtain the Fourier series f of t, Fourier series x of t is equal to a naught plus sigma n is equal to 1 to infinity a n cos n omega naught t plus b n sin n omega naught t. So we need to find the coefficients a naught, which is a DC component, a n and bn. A naught is 1 by t integral t naught to t plus t into x of t dt. An is 2 by t integral t naught to t naught plus t x of t cos n omega naught t dt. Bn is 2 by t integral t naught to t plus t x of t sin n omega naught dt. These coefficients a naught, an, bn are evaluated in a single time period. So a naught is 1 by t integral 0 to t f of t dt. So f of t is from 0 to t by 2, its magnitude is a. From t by 2 to t time period, its magnitude is 0. So on calculation, we will get the coefficient a naught value, which is a DC component, a by 2. Next, calculate the coefficient a. Its formula is 2 by t integral 0 to t f of t cos n omega naught t dt. Again same thing, f of t value from 0 to t by 2 is a. F of t value from t by 2 to t value is 0. So we will get a by n pi sin n pi. Its value is 0 for all values of n. Sin n pi is 0. Bn coefficient 2 by pi integral 0 to t f of t sin n omega naught t dt. Again f of t is from 0 to t by 2, its magnitude is a. From t by 2 to t, its magnitude is 0. So on calculation, we will get a by n pi 1 minus 1 power n. If n is 1, b1 is 2a by pi. For n0, 2, b2 is 0. For n3, 2a by 3 pi. For n4, it is 0. For n5, b5 is equal to 2a by 5. Therefore, trigonometric Fourier series is f of t is DC component a naught, that is a by 2 plus an coefficient is 0 plus bn. So that is 2a by pi sin 1 omega naught plus 1 by 3 sin 3 omega naught plus 1 by 5 sin 5 omega naught and so on. This is a final trigonometric Fourier series expansion for the given waveform. So correct answer is option 1. Question number 63. The quiescent state of transistor is when? So that is biased but no signal is applied. The transistor quiescent state or Q point is its steady DC operating condition with no input signal applied, or the transistor is said to be in quiescent state when no signal is applied to the input. So correct answer is option 2. Question number 64. The current amplification factor in radian square of Colpitt's oscillator is. So this is a circuit diagram for Colpitt's oscillator. The tank circuit of Colpitt oscillator consists of one inductor and two capacitors. So this tank circuit provides 180-degree phase shift and transistor provides 180-degree phase shifts, total 360-degree phase shift, which is one of the condition for oscillator circuit to produce oscillations. The frequency of Colpitt's oscillator depends on the components in tank circuit and is given by frequency f is equal to 1 by 2 pi L under root L C, where C is effective capacitance because there are two capacitors. These two capacitors are connected in series. So equivalent capacitance is C1 C2 by C1 plus C2. The circuit can effectively act as oscillator, producing sustained oscillations by carefully monitoring the feedback ratio as C1 by C2. Its feedback current amplification factor or feedback ratio is C1 by C2. Correct answer option 4. Question number 65. The two input terminals of op amp are connected to voltage signals of strength 745 microvolts and 740 microvolts respectively. The gain of op amp in differential mode is 5 into 10 power 5 and CMRR is 100 dB. What should be the output voltage? Voltage at terminal 1 of op amp is V1 is 745 microvolts and at the terminal 2 is 740 microvolts. Differential gain ADM is 5 into 10 power 5 and common mode rejection ratio is 100 dB is given. So if it is 100 dB, so its value is 10 power 5. CMRR is 10 power 5, ADM is 5 into 10 power 5. Now the relation between common mode rejection ratio, differential mode gain and common mode gain is CMRR is equal to ADM by ACM. We know CMRR value 10 power 5, ADM is 5 into 10 power 5. From this common mode gain is 5. Now VDM is differential mode voltage, VDM is V1 minus V2 and common mode voltage VCM is V1 plus V2 by 2. So V1 minus V2 is 5 microvolts, V1 plus V2 by 2 is 747.5 microvolts. Now the op amp output voltage V0 is equal to ADM differential mode gain differential mode voltage plus ACM common mode gain plus VC into VCM common mode voltage. Output voltage is differential mode gain into differential mode voltage plus common mode gain into common mode voltage. So substitute all the values here. Radium is 5 into 10 power 5 and VDM is 5 microvolts, ACM is 5 and VCM is 747.5 microvolts. On substitution we will get the output voltage of an op amp is 2.5 volts. Correct answer option 4. Question number 66. The given operational amplifier circuit corresponds to which electronic circuit application? Half wave rectification. Let us see the operation of the circuit. If input voltage Vi, if this input voltage is positive, then voltage at the output VOA is voltage at the output of operational amplifier VOA is negative. So when this VOA is negative, the diode D1 will be on and D2 will be off. So VOA is negative voltage. So voltage at that point is negative. So D1 is forward bias, D2 is reverse bias. So D2 is reverse bias. So that means off state. D1 is forward bias. That is on state. So D2 is reverse bias. D1 is forward bias. So from this, the output voltage VO will be 0. Again, when input voltage Vi is negative, if this input voltage is negative, we will get the diode D2 as forward bias and D1 is reverse bias. We will get the output voltage is minus Rf by Ri into Vi. So the circuit acts like a negative feedback amplifier. So the circuit acts like a negative feedback operational amplifier circuit. So the given circuit acts as an half wave rectification. Question number 67. Choose the correct answer from decimal to octal conversion given below. Option 1, 0.125 base 10 is equal to how much? So 0.125, here fractional part is 0.125 is given. 0.125 into 8, because octal conversion, its value is 1. Again take this decimal part, 000 into 8, its value is 000. Now 0.125 base 10 is equal to decimal point 10 base 8. So correct answer is option 1. 0.125 base 10 is equal to 0.1 base 8. Question number 68. Compute output of following logic gates as combinational circuit. So here inputs are A and B and we need to calculate the output. Let output is assumed as Z. So the first gate is NOR gate and the second gate is NOT gate. NOR gate inputs are tied together. Therefore this second NOR gate acts like a NOT gate. So first calculate output Y. Y is equal to A plus B bar. NOR gate output is A plus B whole bar. So A plus B whole bar and Z is equal to Y bar. So replace Y, A plus B bar whole bar, that is A plus B. So circuit acts like the total combinational circuit acts like an OR gate. So correct answer is option 2. Question number 69. The sum of products equation is below given below as y is equal to AB bar plus AB bar C plus ABC bar plus ABC. Identify the correct representation of the above equation form. So SOP terms. A bar BC is 011, it is 3. A B bar C 101, min term is 5. A B C bar 110, min term 6. A B C 111, min term is 7. In SOP expression, the variable is treated as 1 and complement for the variable or variable in complemented form is written as 0. So from this SOP expression is sigma small m of 3567. So correct answer is option 2. Sigma small m of sum of products small m 3567. Question number 70. The truth table of D flip flop is given below. Choose the exact characteristic equation based on the above truth table. If clock pulse is given, for input 0, output is 0. If input is 1, output is 1. So Qn plus 1 is same as input. The output state Qn plus 1, this Qn plus 1 is same as input D. So characteristic equation Qn plus 1 is equal to Dn. Correct answer option 2. Let us see the characteristic equations for other flip-flops. For SR flip-flop, characteristic equation is S plus R bar Qn. For JK flip-flop, J plus Qn bar, J Qn bar plus K bar Qn. For T flip-flop, T Qn bar plus T bar Qn. So it can also be written as T XOR of Qn for T flip-flop. Question number 71. Loop 1 is move A comma P1. Second instruction is move P2 comma A. Third instruction J and B. P3 3 comma loop 1. The program does the following. What is the output of the program? So move A comma P1 is read data from port 1 into the accumulator. Move P2 comma A is write the same data into port 2. So here in first two instructions, data is read from P1 to accumulator and from accumulator to port 2 is written. Reading data from port 1 to accumulator and from accumulator the data is written into port 2. Third line in program is J and B P3.3 comma loop 1. So jump if not bit set, that is if P3.3 is equal to 0, jump back to loop 1. Loop continues until P3.3 becomes 1. So JNB means jump if not bit set. If it set means loop terminates. If it doesn't set means if it is 0 means loop continues. The program continuously read data from port 1 and writes it to port 2. This continues as long as bit 3 of port 3 is reset. The loop stops when P3.3 is set to 1. So here correct answer is option 2. Read data from port 1 and write it to port 2 until bit 3 of port 3 is reset. And this process reading from port 1 and writing into port 2 is continued if bit 3 of port 3 is 0. If bit 3 of port 3 is 1, this process is stopped. Question number 72. In 8086, AL is 19 in BCD and BL is 36 BCD prior to execution of following example. Now the program first line is ADD is equal to AL comma BL and DAA. What will be the content of AL after the execution of an example? Here AL is 19 BCD. So in BCD, 19 can be represented as 0001, 1001 and 36 in BCD as for 3 it is 0011, for 6 it is 0110. Now add AL comma BL, add the content in AL and BL register pairs. So on addition, so we will get its value as so 101, 011, 011, 101. Again 110 carry is 1, 110 carry is 1. So this one can be written in down. Now the lower value is all ones and the higher one is 0100. DAA, decimal adjust after addition. So here lower bit is greater than 9, its value exceeds 9. Now in DAA instruction execution, 6 is added to the lower byte. So once 6 is added, we will get correct answer is 55H. Option 2. Question number 73. The BIU bus interface unit of 8086 contains 16-bit segment registers. What is the width of address sent out by BIU of 8086 microprocessor? Bus interface unit. It provides an interface of 8086 to external memory and IO devices via system bus. This BIU performs various machine cycles such as memory read, IO read, etc. to transfer data between memory and IO devices. BIU performs the following functions. It generates 20-bit physical address for memory address. It fetches instructions from the memory, transfers data to and from memory and IO devices, maintains 6-byte prefetch instruction queue. BIU mainly contains 4 segment registers, instruction pointer, prefetch queue, and a address generation unit. The correct answer is 20-bit. It generates 20-bit physical address for memory access. BIU of 8086, word size or data size is 16 bits, address bus size is 20 bits, so 8086 BIU can send 20-bit addresses. Question number 74. If SS is 3000H, SP is 2000H in 8086 microprocessor, in which memory address the contents of BL and BH are stored respectively when push BX instruction is executed. Given SS is 3000H, SP is 2000H, instruction is push BX. Step 1. Update stack pointer. Initial value of the stack pointer is 2000H. After push instruction, stack pointer value is decremented by 2. 2000H minus 2 value is 1 FFEH. Step 2. Stack base address is segment address SS into 10H. 3000H into 10, that is 30,000H. Next, memory address used 30,000H plus 1 FFE. For BL, 1 FFE. For BH, 31 FFF. Its value is incremented by 1 here. So correct answer option D. BL register 31 FFE, BH register 31 FFFH. Option 4. Question number 75. An elliptical polarized wave has an electric field of E is equal to sine omega t minus beta z ax cap plus 2 sine omega t minus beta z plus 75 degrees ay cap volt per meter. The power per unit area covered by the wave in free space is given. Electric field component E bar is sine omega t minus beta z ax cap plus 2 sine omega t minus beta z plus 75 degrees ay cap volt per meter. So average power is 1 by 2 E square. E is written as under root of Ex square plus Ey square, where eta is intrinsic impedance of the medium and its value for free space. Eta for the free space is 120 pi or 377 ohms approximately. Here Ex value, the component of x component of electric field is 1 and y component of electric field is 2. Now E square is Ex square plus Ey square. Substitute the value of E square and eta value in average power expression. So E square by 2 eta, 5 by 2 into 120 pi, and the average power is 6.6 watt per meter square. 6.63 milliwatt per meter square. 10 power minus 3 can be written as milli. Correct answer option 2.